Hello folks, I was experimenting with Kali Linux, trying to install it as a Docker image on an Ubuntu server. So just think about it. Kali Linux is a distribution or distro of Linux. It's mainly focused on security research, computer forensics, and reverse engineering. So I've been trying to install this distribution of Linux in another distribution of Linux called Ubuntu Linux. However, with Docker, I'm not installing the full Kali Linux, meaning an operating system with apps and windows and graphics and menus. However, I'm installing the interface version of it, which is just text-based. You can still run the Kali Linux tools in a text-based environment. I'll admit the installation process to install Kali Linux as a Docker container takes a very long time. We're at the 55% mark and it's asking me for permissions to, just to revert. What I did is I downloaded the Docker image for Kali Linux. Then I started Kali Linux. I then executed a command inside the Kali Linux container to install all the Kali Linux packages, which is all the testing packages, the security type packages for Kali Linux. So during the installation process, it brings me to this stage where it says a tool or package of Kali called Kismet. It needs root privileges for some of its functions. However, running it as a root is not recommended since running all the code with elevated privileges increases the risk of bugs doing system-wide damage. Instead, Kismet can be installed with the set UID bit set, which will allow it to grant these privileges automatically to the processes that need them, excluding the user interface and packet decoding parts. So it's asking me to accept whether or not I would like to go ahead with this set UID process. I will go ahead and say yes. Enter. Only users in the Kismet group are able to use Kismet under the set UID model. Add users to, users to add to that group. Note that currently logged in users who are added to a group will typically need to log out and log in again before it is recognized. Wait, I'm running this as root. Let me press enter and see what happens. Okay. Setting up Kismet. What I'm trying to achieve here is this. As you'll notice, there are so many different distributions of Linux. Each has its flair, so to speak. I like Ubuntu Linux because the desktop interface looks nice. And it was the first it was the first Linux distribution that I ever used. So I've gotten used to it over the years. However, I also like Fedora. Fedora is good because it's developed by Red Hat. And I also like CentOS. Fedora is the desktop distribution that's developed by Red Hat. And then there's CentOS. CentOS is the server distribution of Linux that's also developed by Red Hat. And then Red Hat also has the Red Hat Enterprise Desktop and Red Hat Enterprise Server. Kali Linux is known for the security tools, the pen testing, computer forensic tools. So what I'm trying to achieve here is the ability to run whatever Linux distribution you prefer as your main desktop, and then the extra ability to install other Linux distributions as Docker containers. Okay, a prompt, please specify whether MAC changer should be set up to run automatically every time a network device is brought up or down. This gives a new MAC address whenever you attach an Ethernet cable or re-enable Wi-Fi. This is so cool. It changes the MAC address of the computer, but do I want it to automatically run every time a network device is brought up? Well, since I'm running this as a Docker container, I don't mind, so I'll do yes. If I was running Kali as my desktop, then I would have probably said no, because I don't want my desktop to pick up a new MAC address every time I power it on. A MAC address is, you've probably heard about IP addresses. An IP address is, for example, the server that I'm installing this container has an IP address of 10.0.3.9. However, a MAC address is built into the computer. Every device that either connects to the network with a network cable or connects to Wi-Fi has a MAC address. It's this alphanumeric address with 12 characters in groups of 2 separated by colons. For example, A1:25:C3:15, something like that. So whenever a device connects to the network for the first time, the router sees it using the MAC address. Then the router will say, hey, MAC address ABCDEF123456. Your IP address is now 10.0.3.10. So going back to that response that I gave about generating a new MAC address each time, what this would mean is this was my desktop and I have that tool or package running. Each time I turned it on, the router will think it's a new computer and give it a new IP address. And that's not nice, because in every home where there's a router, either Wi-Fi or wired, your computers usually, or your devices usually keep the same IP address for at least 8 days. And then if the same device is still available on day 9, the router just assigns the same IP address. Okay, so what's going on here? We are installing the packages that are needed to have a fully running Kali Linux server, so to speak. I'm referring to it as a server because it won't have a graphic user interface. Just to bring this back again, I am installing a Kali Linux Docker container on an Ubuntu Linux server. And in my case, that Ubuntu Linux server is running as a virtual machine Hyper-V on Windows 10. I'll stop the recording for now. I'll come back if another prompt comes up. See you in a few. I've been mentioning containers over and over again, but I haven't defined what containers are. Let's look at this description here from docker.com. A container is a standard unit of software that packages up code and all of its dependencies so the application runs quickly and reliably from one computing environment to another. A Docker container image is a lightweight, standalone, executable package of software that includes everything needed to run an application code, runtime system tools, system libraries, and settings. Container images become containers at runtime, and in the case of Docker containers, images become containers when they run on Docker Engine. Available on both Linux and Windows-based applications, containerized software will always run the same, regardless of the infrastructure. Containers isolate software from its environment and ensure that it works uniformly despite differences, for instance, between development and staging. There's an image here that illustrates the same. In green is the infrastructure, which would be the physical hardware, for example, a desktop computer or a server. Then above it, we have the host operating system. It could be Mac OS, it could be Windows, or it could be, in my case, Ubuntu Linux. Then Docker is installed inside of the operating system as an application. And inside of Docker, we have the containers that can either run as completely isolated environments or connected. And if they run as connected, they form what is referred to as a microservices architecture. Here's a definition here from Google Cloud. Microservices architecture, also or often shortened to microservices, refers to an architectural style for developing applications. Microservices allow a large application to be separated into smaller, independent parts, with each part having its own realm of responsibility. To serve a single user request, a microservices-based application can call on many internal microservices to compose its response. Containers are a well-suited microservices architecture example, since they let you focus on developing the services without worrying about the dependencies. Modern cloud-native applications are usually built as microservices using containers. So that's my take on what containers are. Let's go back to the Kali Linux installation. Looks like it's done. I'm going to try and run some tools which are available in Kali Linux and see what happens. I'll run this one called AIX to John. Okay. -H for help. There it is. It's running. I'm running a Kali Linux tool. So AIX to John is what this one is called. I'm going to try out a tool called Crunch. It's a Kali Linux tool as well. So Crunch is meant to help us generate a dictionary file containing words with the minimum and maximum length of whatever we define using given characters and then saving the output to a file. So in this example, we're going to crunch up a dictionary file containing words with minimum and maximum length of 6. So words with 6 characters, minimum characters, maximum characters, minimum of 6, maximum of 6, and then these words should contain these characters. So I'm going to type out the characters that I want these words to have, and then I'm going to save them to a text file, and I'll call this that, and enter. Crunch will now generate the following amount of data. That's 7 million bytes, which is 7 megabytes. And then Crunch will now generate the following number of lines, which is 1 million lines. Crunch completed generating output. So where is that going to move? I'm going to move that file to the root directory. To root, and there it is. And these are the contents. So what it does is it just generates random combinations of characters. We have successfully installed or spun up a Kali Linux container on Ubuntu server. This is Ubuntu server. We're running Ubuntu server 22.04.3, and this is the LTS version and codename Jammy. Let us load Kali. So we're going to use the Docker run -IT, and that's the image of Kali Linux, which we have already downloaded. Press enter. And Kali Linux is now running, and we have an active prompt in Kali Linux. So if I run the previous command, lsb release, nothing. However, if we run this, you notice that we are now in Kali Linux. Thank you for visiting Red Alt Key. Don't forget to subscribe, like this video, or comment. See you on the next video. Bye.